So dear students, in the last lecture we have seen that what is the method of partial fraction and how to use method of partial fraction to find the inverse Laplace transform. Okay, now we will move to the next topic, that is the use or differentiation of f of s. So your topic is use of differentiation of the function f of s. Okay, see here. So effect of multiplication on t, you know very well. Okay, in that what I have to do, if Laplace transform of the function f of t is equal to what, f of s. Okay, then we write Laplace transform of t raised to n f of t is equal to what, minus 1 raised to n minus 1 uh, raised to n d raised to n by ds raised to n, and this is what, f of s. Okay, that is, if L inverse of f of s, L inverse of f of s equal to what, f of t, then we write L inverse of f of s, L inverse of f of s equal to minus 1 by t L inverse of L inverse of d by ds f of s. Okay, d by ds f of s, and we will use this formula to find inverse Laplace transform of the given function. Okay, let us see how to use this formula to find inverse Laplace transform. So example find the inverse Laplace transform of inverse Laplace transform of transforms of log of 1 minus 1 upon s square. Okay, log of 1 minus 1 upon s square. So let us see how to find inverse of this function. Solution, what is given to you, just write down, given that f of s, f is the function of s, equal to log of 1 minus 1 upon s square is given to you, and we have to find out the inverse of this function f of s. Okay, so for this what I have to do, we will use our differentiation of f of s to find the inverse. So using differentiation of the function f of s. Okay, we write L inverse of f of s, L inverse of f of s is equal to what, 1 upon t, negative of 1 upon t, L inverse of d by ds, and f of s, d by ds f of s. So what is f of s? Just substitute the values of f of s. So therefore L inverse of your f of s is log of 1 minus 1 upon s square. Okay, and this equal to minus 1 upon t as it is, then L inverse of d by ds, and f of s is log of 1 minus 1 upon s square. Okay, so this can be written as negative of 1 upon t L inverse d by ds. So before taking derivative of this function, we just simplify the function first, then apply the derivative. So we cross multiplying, you will get s square minus 1 divided by s square. Okay, now apply the properties of logarithm. So this equal to minus 1 upon t, properties of logarithm just apply. So this is what? This equal to minus 1 upon t L inverse d by ds, open the bracket, curly bracket. So we apply the properties of logarithm. So log of a by b can be written as log a minus log b, that is log s square minus 1 minus log s square. Okay, just close the bracket. So this equal to negative of 1 by t L inverse, just apply the derivative inside the bracket. So L inverse d by ds log of s square minus 1 and minus d by ds log of s square. Okay, just close the bracket. Now take derivative of the function. So this is equal to negative of 1 upon t L inverse of, take derivative with respect to s. So this is 1 upon derivative of log x is what? 1 upon x, but this is not x, this is s square minus 1. So we will take derivative of s square minus 1 again. So this become what? S square minus 1, and derivative of this function is again, so you will get 2s. Okay, so whole thing is what? 2s by s square minus 1 and minus, now same thing here. So what is the derivative of log x? That is 1 upon s, 1 upon x. So but this is not x, this is s square. So this is s square, and derivative of s square is again, you will get 2s. Getting? Close the bracket. So what is the common here? 2s is common. Okay, but we will take here 2 only common. So we taking 2 outside, so this become negative of 2 by t L inverse of s divided by s square minus 1, and minus 1s will cancel, so this become 1 upon s. Now close the bracket. Okay, now let us move to the next page, then we will apply the inverse inside the bracket. Therefore we write L inverse of log of 1 minus 1 by s square. Okay, this is for left hand side, and this equal to minus 2 by t L inverse of, we writing the last step once again, s upon s square minus 1. So s upon s square minus 1 and minus 1 upon s. Okay, minus 1 upon s, just close the bracket. So this equal to negative of 2 by t, apply inverse inside the bracket. So this is what? L inverse of s upon s square minus 1 minus L inverse of 1 upon s. Okay, so this equal to negative of 2 by t, and what is the inverse of this? S upon s square minus 1, that is hyperbolic cosine t. Okay, because here minus sign. and minus, what is the inverse of 1 upon s? What is the inverse of this?
1.
Yes, 1. So inverse of this is 1. Okay, just write in systematic way. So we multiply 2 inside, so this become, we multiply negative sign inside the bracket, so this become 2 by t, and 1 minus hyperbolic cosine t. Okay, so this is your require inverse Laplace transform of the given function. I hope you understood this problem. Yes or no, student?
Sir.
Let us take another problem. Example number 2. Okay, so find inverse Laplace transform of the function which function is given to you, log of s square plus a square, and divide by s plus b the whole square. This function is given to you. Okay, let us find the inverse Laplace transform of this function. So solution of this, so we first write down the given function is equal to f of s. So write down given function, so f of s equal to given function, that is what, s square plus a square and divide by s plus b the whole square. Okay, again use of differentiation of f of s. So again using differentiation of the function f of s, we write L inverse of the function f of s, and this is equal to negative of 1 by t L inverse of derivative of function f of s with respect to s. Okay, your function is what? Just this, log of s square plus a square divided by s plus b the whole square. So therefore your function is what? Log of s square plus a square and divide by s plus b the whole square. This is your function. Okay, and this equal to negative of 1 upon t L inverse d by ds. F of s is this function, log of s square plus a square and divide by s plus b the whole square. Okay, before taking inverse of this function, we must differentiate this. Okay, so just write down this equal to negative of 1 upon t L inverse d by ds. We just simplify bracket first. So this log a by b can be written as log a, that is s square plus a square minus log b, that is what, s plus b the whole square. Okay, now close the bracket. This equal to negative of 1 by t L inverse of, just differentiate this. So d by ds log of s square plus a square first bracket minus d by ds. Okay, d by ds log of s plus b the whole square. Okay, just close the bracket. Differentiate this, so minus 1 by t L inverse as it is, derivative of this is log x. Okay, what is the derivative of log x? 1 upon x. So पहले s square and plus a square, but this is not log x, this is s square plus a square. So we will take derivative of this again. So you will have 2s, we have 2s, so this is 2s by s square plus a square, okay, minus, and take derivative of this. Derivative of this is what? Derivative of log s plus b the whole square, okay. So s plus b the whole square, okay, and derivative of this s plus b the whole square is again, so that is what? 2 s plus b, and we will take one more time derivative, so this become what? 1, and constant term 0, so there is no need to write, okay. So yes, now 2 or 2 is here in the numerator, just we will taking common. Let us move to the next page. So therefore L inverse of log of s square plus a square, s square plus a square, and divide by s plus b the whole square. Is this right your function? Okay. Then we will take 2 outside because 2 is the common in each term. So this become negative of 2 by t. So this equal to negative of 2 by t L inverse s upon s square plus a square, s upon s square plus a square, negative sign, one factor will cancel from this, so this become 1 upon s plus b, okay. So 1 upon s plus b, close the bracket. Now what? Just apply the inverse Laplace transform inside the bracket. So this is 2 by t, okay, big bracket, L inverse of s upon s square plus a square, this is first term, minus L inverse of 1 upon s plus b, okay, just close the bracket. So this equal to negative of 2 by t L inverse of s upon s square plus a square is what? Cos at minus L inverse of 1 upon s plus b is e raised to minus bt, okay, e raised to minus bt, multiply minus 1 inside the bracket, so this become what? 2 by t e raised to minus bt and minus cos 8t, okay. So this is your required inverse Laplace transform of the given function. I hope you understood this problem also. Yes or no?
Yes, sir.